This is one of them, and I want to explain to you why it has nothing to do with design. It is weird and strange that we live in a universe that looks like we do, because this is a brief history of time. This is the density of matter as the universe expands. It goes down as 1 over the volume. But it turns out the energy density of empty space remains constant as the universe expands. And we live today, right here, when the energy density of empty space is 3 times bigger than the energy density of matter. But when you look at this has driven physicists crazy. Because this is the only time in the history of the universe when these two numbers are about the same. At all earlier times, the density of matter was much greater. At all later times, the density of empty space will be much greater. Why do we live at this special time in the history of the universe? Well, one of the answers that's been given is that these things exist, galaxies. Why? Well, let's go back to this picture, and let's pretend the energy of empty space were 50 times bigger. Then these two curves would cross, not now, but then. Well, when is then in this case? Then is the time when galaxies first formed. But if the energy of empty space was bigger than the energy density of matter when galaxies first formed, then the repulsive force would be greater than the attractive force. Galaxies would never have formed. Well, if galaxies never formed, then maybe this is telling us something. And this has produced something that I call anthropic mania. If there are many different universes, physicists have argued, and the energy of empty space can vary in each one, then only in those in which it's not much greater than what we measure today will galaxies form. Okay? But then, only then will stars and planets form, and only then will astronomers form. So the universe is the way it is because astronomers are here to measure it. Now, it not only sounds ridiculous, but it also sounds religious. And some people have said the universe is fine-tuned. If it were any different, then we wouldn't be here. God clearly created the universe to be for us. Now, that's nonsense. And it's nonsense for the same reason that you learn so beautifully in Richard's books. Why can bees tell the colors of flowers so they can find them? Not because God intended them to do it, but if they couldn't find the flowers, they wouldn't get the stuff they needed to eat, and they wouldn't be around. It's natural selection. And what this is really telling us is kind of a cosmic natural selection. Because all it's saying, if it's true, is that it's not too surprising that we find ourselves living in a universe that allows life. Because in the universes that don't allow life, we wouldn't be here. It's just that simple. So if you wish, it's a kind of cosmic evolution. Or cosmic natural selection is a better way of thinking about it. Now, as pretty as that is, I think it's wrong. It's ugly. And it goes against everything I know about science. Science has told us the last 400 years why the universe must be the way it is, not why it has to be something different. In fact, Einstein once asked a question. He said it the wrong way. Put it here because, I wanted to quote him. He said, what really interests me is whether God, and by God he didn't mean God, had any choice in the creation of the universe. What he really meant is, are the laws of physics fixed so that if you changed one parameter, you couldn't have a universe? Or can you have infinite numbers of different laws of physics that all work, and it just happens to be the way it is? If this anthropic picture is right, then physics is really an environmental science. There's no fundamental laws necessarily. We're just here by an accident. And the laws of physics are the way they are, not because there's some beautiful mathematical theory that tells us they have to be, just because if they were different, we wouldn't be here. Now that I find repugnant, although it may be true. And I was going to spend time telling you about that, but I'm really behind, so maybe I shouldn't. Let me just say that there is a theory that suggests, in such a picture, if there are an infinite number of universes, then you don't need a theory of everything. Forget what I wrote there. You need a theory of anything. You just need an infinite number of universes and some theory that tells you anything can happen. We have such a theory, and I did want to spend 1 minute telling you about it. It's called string theory. Here's the brief summary of it. One person said to another, I just had an awesome idea. Suppose all matter and energy is made of tiny vibrating strings. The second guy says, okay, what would that imply? And the first guy says, I don't know. So that's the history of string theory in the last 25 years. And The point is, it is fascinating for many people, but one of the things it might predict is that anything is possible. And if anything is possible, it's not clear you have a scientific theory at all. But now, I'm going to skip forward. In the last minute, I had a good joke about George Bush, but I won't give it. And I'm going to skip this. I'm going to skip this. Forgive me, it's really interesting, but I want to get to the very end, which will really tell you about how miserable our future really is. And it should give us a kind of cosmic humility, which is the other thing that should be characteristic of science. A humility, the recognition that we don't understand everything. Bill Maher talked about it last night. What pompous assholes like Rick Warren, who claim to understand everything, are an anathema to science. We should realize that there's more we don't understand about the universe than we do. And I want to give you an example of this. The far future. What's going to happen in the far future? Remember, 100 years ago, we thought we lived in a static, eternal universe. What will the future bring? The amazing thing is, for civilizations that live in the far future, what will they see? Well, the universe is accelerating. That means all the distant galaxies are getting carried away from us, and eventually they'll move away from us faster than the speed of light. It's allowed in general relativity. They will disappear. The longer we wait, the less we will see. In 100 billion years, any observers evolving on stars around and there will be stars just like our sun in 100 billion years, any observers on civilizations evolving around those stars will see nothing except for our galaxy, which is exactly the picture they had in 1915. All evidence of the Hubble expansion will disappear. Why? Because we won't see the other galaxies moving apart from us. So they will have no evidence, in fact, of the Big Bang. They won't see the Hubble expansion. They won't even know about dark energy, and I won't go into that. They won't know about the cosmic microwave background. It will disappear too. It will redshift away, and it turns out, for fancy reasons, there's a plasma in our galaxy, and when the universe is 50 times its present age, the microwave background won't be able to propagate in our galaxy. All evidence of the Big Bang will have disappeared. And those scientists will discover quantum mechanics, discover relativity, discover evolution, discover all the basic principles of science that we understand today, use the best observations they can do with the best telescopes they will build, and they will derive a picture of the universe which is completely wrong. They will derive a picture of the universe as being one galaxy surrounded by empty space that's static and eternal. Falsifiable science will produce the wrong answer. In fact, I want to end with the good news. We live in a very special time. The only time we can observationally verify that we live in a very special time. Okay, it's clear I'm being facetious. What it really should tell us is we've discovered this crazy picture of the universe that we don't understand at all. It all holds together. But maybe if we had evolved 5 billion years earlier, it would have been observable as we could have seen it, would have changed that picture. Maybe 5 billion years in the future, it'll be different. The universe remains mysterious. And that is great. But I do want to say in the far future, this is the picture. We will be lonely and ignorant, but dominant. And those of us who live in the United States are used to that. Let me end. Okay, that's the end. Thank you. Thank you. On the one hand, the Woody Allen of cosmology. We've been privileged to hear and witness the scientific mind at full stretch in all the excitement that it can bring. And I'm delighted that we've had this talk today. What grieves me is that at least in Britain, and it may be true here as well, young people going to university are voting with their feet and not going into physics. They're going into media studies. Despite the enormous excitement that is in physics and cosmology, despite the fact that, as Lawrence said, the Large Hadron Collider is even now about to revolutionize the way we think about ourselves. There was a misprint in my book, just finished, The Greatest Show on Earth. I referred to the Large Hadron Collider. It got rendered as the Large Hard-On Collider. That's okay. That's okay because that's what physicists are getting right now.
Yeah, I know.
Okay.
Physicists are getting I spotted it, and I prayed that the publisher's copy editor, the publisher's proofreader, wouldn't spot it, and she did, and I pleaded with her to leave it in, and she said it was more than her life was worth. So, Lawrence, thank you. We have a few minutes for questions.
Oh, we do? Oh, good.
I think we do. I mean, actually, it's cutting into your book signing. Which would you rather do?
I'd rather answer questions.
Okay.
I'll be around all day. So.
Okay.
Well, the question was, are people who involved in general relativity more religious than other scientists? Which apparently Steve said when Richard and he had a dialogue.
I have no memory of him saying that.
Yeah, that's great. And there are some great interviews you should watch of Richard. One of them was with me. But anyway, we had fun. I think that, no. I mean, there are a few. There's a famous general relativist who's now unfortunately become a nut named Frank Tipler, who I've actually debated right near here at Caltech a few years ago. And there are some, but I don't think that's true in general. There are a few. There's one or two. I don't think there's any evidence of that. What is true and is interesting, and I think I will answer in a more relevant way, is that general relativity unfortunately gives people the wrong idea about science. And unfortunately I get a lot of letters from crackpots because of it. Everyone imagines Einstein sat in a room, closed doors, and thought of this picture and came up with this beautiful theory independent of reality, like string theorists. Okay? And the answer is that's not true at all. Einstein was guided by experiment, was guided deeply by experiment, not just the thought experiments he did in his mind. But if you read what Einstein said, after he developed general relativity, okay, one of the first calculations he did was the orbit of Mercury around the sun. And the orbit shifts a little bit, this perihelion moves. And no one understood why that was. And he said, he calculated that what should happen in general relativity, it moved. And it moved by exactly the right amount. And he said, he almost fainted. Because that was the moment that he knew was the right theory. And so, it's not as if scientists are out of touch with experiment and come up with pictures like religion that are just beautiful, that they believe because of their intrinsic beauty. As beautiful as general relativity was, Einstein would have thrown it out like yesterday's newspaper if it had come up with the wrong answer for the perihelion of Mercury.
Yeah. My question is probably easily answered, but if quantum fluctuations are able to actually produce universes, even though that may be extremely improbable, is there ever a chance we might actually observe another universe being created?
It's a really good question. People wonder actually it's one of the questions people worry about with the Large Hadron Collider. Maybe you'll create this universe. And whether you can create baby universes in the laboratory is still an open question. There's lots of evidence that suggests you can't. You can't actually physically create the energy conditions necessary. But we don't know for sure. It's one of these open questions that people like me get paid to think about. But interestingly enough, and this is one of the wonderful things about general relativity, is if a universe got created, an inflating universe like the one we think we began in, it's really weird. Because from the inside, it would look like it was growing exponentially. From the outside, it would look like it was shrinking to form a black hole. So, it's not so clear that we would know about that. Okay? Now, we do think, and the current picture of the best picture of cosmology involves something called inflation right now, and it suggests that our universe that we see is just part of a multiverse in which there are other regions where there may be universes just being created now. But because those regions are literally moving away from us faster than the speed of light, we will never know about them periodically. So it's not as if those inflating universes collide. As fast as they expand, the space between them is expanding faster. And so, unfortunately, these are right now, in some sense, metaphysical pictures. And what we want to do is learn enough about the fundamental physics of places like the Large Hadron Collider to know if there are other observable implications that we can measure, just like we believed in atoms a long time before we saw atoms, because all the other implications agreed with experiment. So it may be that we never know about those other universes directly, but we have a theory that tells us, that explains the mass of the proton, the mass of the electron, but it also tells us that those other universes exist. We would be willing to accept them without seeing them. Okay?
Thank you.
Sure. Take a few more. Okay.
Hi. Hopefully there's no stupid questions. So
there are no stupid questions.
I'm wondering, how do you wrestle with infinity? For example, it seems like all your thinking and what allows what it has to do with a finite amount of matter. You were talking about multi-universe
Yeah, sure.
and stuff. Well, in my head, there's just one universe, all those multiples.
Well, in a flat universe, it's infinite in spatial extent, right?
Uh-huh.
Infinity is a really hard thing to wrestle with.
Yes.
And in fact, let me give you, in one of my books I wrote about infinity because it's so fascinating and so weird. The only way you can wrestle with infinity is, unfortunately, the way we physicists wrestle with many things, mathematically. And fortunately or unfortunately, mathematics is the language of nature. And therefore, every time I give a talk or write a book, I have to lie a little bit because I put it in words. The real explanation is mathematical. But infinity is so strange, you don't have any idea how strange it is. So let me make it clear to you how little you understand infinity. Okay?
No problem.
I'll use the example of a very famous mathematician called Hilbert. Probably the most famous mathematician in the early part of the century. He almost discovered general relativity before Einstein. Hilbert gave an example. We call it Hilbert's Hotel. And I like to use it. So let's say you go to Las Vegas and there's an infinitely big hotel. Okay? And you go in and you go in and say, I want a room. And the clerk says, well, all the rooms are occupied. You say, okay, I'll leave. And he says, no, it's okay. I can handle that. Here, let me just move the person from room number 1 into room number 2. The room number 2 into room number 3. Room number 3 into room number 4. And so on. Now all the other rooms are occupied, but room number 1 is empty. Okay? That seems a little strange, but let's say you have a Catholic family that's infinitely big. And you go to the hotel and say, I've got my infinite number of children here. I want to check in. He says, well, the rooms are occupied. And you go, oh, okay. And he says, no, I can handle that. I can handle your infinite family. Even though I'm fully booked, I have an infinitely big hotel. I move someone from room number 1 into room number 2, room number 2 into room number 4, room number 3 into room number 6, and so on. And now all the even numbers are occupied. And all the odd-numbered rooms are empty, so you have an infinite number of those. So you see, infinity, working with infinities, is really weird. Because adding and subtracting infinities produces strange things. And unfortunately, in physics, we have to learn how to deal with that. The universe may be infinite. And there are many strange things. One of the most ridiculous, unfortunately, which I go to physics conferences, I was just in one in France, and this was talked about, is if the universe is infinite and infinitely old, then there's a puzzle. We're here because we evolved. But that makes us very special, apparently. Because if the universe is infinitely big and infinitely old, quantum fluctuations will produce this room with all the people in it. Having everything is exactly the same. Yeah. An infinite number of times. Exactly. So we should be in this room, and I know it seems like it's taking an infinitely long amount of time, but we should be in this room, but most of the time, we should never have evolved. But we evolved. That's caused some physicists to worry. I think it's a ridiculous worry, frankly, because in fact, and I hate to do this. I'll answer your questions in private later, but because I want to let people, go pee and stuff before the next thing. But let me just say to close, because probably this is the most important moral of infinity, and it comes from Richard Feynman, who I've just written a book about. Richard Feynman used to go up to people all the time, and he'd say, "You won't believe what happened to me today. You won't believe what happened to me." And people would say, "What?" He'd say, "Absolutely nothing." Because we humans believe that everything that happens to us is special and significant. And Carl Sagan wrote beautifully about that in Demon Haunted World. That is much of the source of religion. Okay? Everything that happens is unusual, and I expect the likelihood that Richard and I ever would have met, if you think about all the variables, the probability that we were in the same place at the same time, ate breakfast at the same, whatever, if you apply, it's zero. Okay? Every event that happens has small probability, but it happens. And then when it happens, if it's weird, if you dream 1,000,000 nights and it's nonsense, but one night you dream that your friend is going to break his leg and the next day breaks his arm, and you think, okay? So the really thing that the physics tells us about the universe is it's big. Rare events happen all the time, including life. And that doesn't mean it's special. Thank you very much.